So let's apply this law of Biot-Savart to long wire. So we've got a long wire right here, and the wire has some current I in it, and I'm going to imagine that I am some distance right here, capital R, away from there, and I want to know what's the magnetic field right there. Okay, so we know that, we got some little ds right here, and there's going to be an r right there, and so the r hat is like that, and ds is in the direction here. So what you find is that would be a magnetic field out of the board. If it's down here, that's a magnetic field into the board. A way of thinking about it is right-hand rule. Put your thumb in the direction the current is going, and your fingers curl around the wire in the direction the magnetic field goes. So in other words, if the magnetic field is, if the current's coming straight at you, so that'd be like putting your eye right here and looking at it. So the current's coming right at you, the magnetic field would be looping around in that fashion. If you put your eye at this end and look down the back end of the wire, so now the current is going away from you, then the magnetic field is going to be going clockwise around there. Okay. So back to my wire. So we got I right here. We got some kind of ds right here. That's some capital R right there. And so what I want to do is I want to integrate, that the b is going to be integral of dB. Okay. And so that's my strategy here, is now to integrate that. Okay. Well, what we can do is we look at this and say, well, this isn't too bad. Okay. So the magnetic field due to this half of the wire turns out to be a mirror image of the magnetic field here. They're both going to be likewise out of they're both out of the board up here. And so since it's symmetric, that means if I call that 0 and then this the long end of the wire here, and I'm just going to say this is like an infinitely long wire, okay, or I can do that later. So it's a really long wire out here, but if I assume it's infinitely long, then this would be 2 times the integral 0 to infinity right there. Okay. All right. So that means that all I have to do is find that integral. So that's going to be 2 times, again, we know that the mu naught I over 4 pi comes out. There'll be 0 to infinity of the ds cross r hat over r squared. So that cancels that. That makes it 2. Okay, now, what is the ds cross r? ds is going to be basically like a dx right here, okay? So this is going to be like a dx right there, okay? So this is dx, okay? And so that means that ds cross r hat, is going to be dx times sine theta, where there's theta right here, okay? And so now, what's sine theta going to be? Sine theta is going to be basically r over r. Well, that's r right there. Okay. All right. So r is going to depend on what is the x here. So r is going to be square root of x squared plus r squared. Okay, so that means putting all this together, okay, so we start putting all this together. So b is mu naught I over 2 pi, because the 2 and the 4 canceled, integral of ds cross r hat over r squared. And so that's going to be mu naught I over 2 pi times the integral of, again, this is dx, the ds is dx, so dx sine theta over r squared. And so that becomes mu naught I over 2 pi integral of r dx over r cubed. Okay, and then the r doesn't do anything. We're going from 0 to infinity up here. And so mu is mu naught I r over 2 pi, because that's a constant, integral 0 to infinity of dx over x squared plus big R squared to the 3/2. So there is my integral. Mu naught I r over 2 pi integral 0 to infinity of dx over x squared plus r squared 3/2. How do I do that integral? Okay, there's a lot of ways of doing that you learn in calculus. I'm going to do it by method of integral table, integration by integral table. So on page A11 in your textbook in the appendix, this is integral number 19. Okay, so this integral is in the back of your book. Okay, and so that integral turns out to be equal to x over r squared times x squared plus r squared to the 1/2. We evaluate that at 0 and infinity. Okay, well, this r comes out, so we get mu naught I over 2 pi r, and now we have x over x squared plus r squared to the 1/2 at evaluate 0 and infinity. Well, at infinity, L'Hopital's rule tells you that's equal to 1. Okay, and so because you've got infinity at the top, infinity squared plus a finite number is infinity squared. Take the square root of infinity. Infinity over infinity is 1. Okay, and at 0, that's 0. So that means the total magnetic field is mu naught I over 2 pi r. So that's the magnetic field of an infinitely long wire. Depends on this mu naught term, depends on I, and depends on how far you are from the wire.